All right, listeners, buckle up because today we're diving deep into a pretty fascinating corner of AI research.
Yeah, this one's a real head scratcher, in a good way.
We're talking about how to make AI better at, well, thinking, and not just the number crunching kind of thinking. We want AI that can reason, think logically, maybe even get a little philosophical.
Exactly. We've all seen how amazing LLMs are at math, generating code and all that. But when it comes to things like logic puzzles or scientific reasoning, they kind of fall flat.
It's like they haven't quite grasped those abstract thinking skills, huh?
Right, like they're missing a piece of the puzzle. But this research we're looking at today might have actually found the missing piece. It's called CodeI.
CodeI. Okay, I'm intrigued already. This method is all about using code, as in computer code, to teach AI how to reason better.
That's the gist, yeah. It's this really clever idea of using the logic built into code as a training ground for AI.
Okay, I'm going to need you to break that down for me a bit. How does that even work?
Think of it like this. Code has a very specific structure, right? It has rules, it has logic, and it produces a clear output based on the input you give it.
Right, I get that. Code is all about instructions and actions, but how does that translate to teaching AI how to, think about the world?
Well, the researchers behind CodeIO and its souped-up version, CodeIO++E, realized that this structured logic within code is actually a gold mine for teaching AI those higher-level reasoning skills that we were just talking about.
Okay, so we're not just teaching the AI how to code, we're using code to teach it how to think.
You got it, and it turns out that code might actually be a much richer training ground for AI than all the text data we usually feed them.
Interesting. So instead of novels and articles, we're giving AI coding manuals and algorithms.
Sort of. They actually collected this massive data set of code from all sorts of places. Like, they used existing data sets like CodeMix and PyEduR, but they also pulled code from algorithm repositories, online coding platforms, you name it.
So a real mix of coding styles and problem-solving approaches.
Exactly. They wanted to capture as much diversity in reasoning as possible because just like humans learn to think in different ways, they wanted the AI to be exposed to a variety of approaches.
I like that. A well-rounded AI education. So how do they take all this raw code and turn it into something an AI can learn from? It's not like you can just feed lines of code into an AI and expect it to become a logician.
Right. It needs a bit more finesse than that. That's where the magic of DeepSeek V2.5 comes in. It's a large language model they use to kind of translate the code into a format the AI can digest.
DeepSeek-V2.5 sounds cutting edge.
Oh, it is. It's known for being really good at understanding the nuances of code and transforming it into a structured, executable format, kind of like prepping all the ingredients before you start cooking.
I like the cooking analogy. So DeepSeek is basically making the code understandable and organized for the AI.
Exactly. Cleaning it up, adding structure, making sure it can actually be executed to get results. They even add what they call a main entry point function that summarizes the core logic of the code.
Ah, so like a thesis statement for the code.
Yeah, I like that. A good way to put it. So now we have all this clean, structured code ready for the AI.
Okay, so what happens next? How do they actually use this code to teach the AI how to reason?
So they run the code and generate a ton of input-output pairs. Think of it like showing the AI a recipe and then the finished dish.
Ah, so the AI is learning to connect the steps in the code, the recipe, to the final result, the dish.
Precisely. And by seeing tons of these examples, the AI starts to learn the underlying logic that connects the two.
It's like learning by observation. Watch a master chef work and try to figure out their secrets.
Perfect analogy. But Codio takes it a step further. They then create prompts using these code snippets and the input-output pairs.
Prompts. So they're challenging the AI to like predict the output based on a certain input and code.
That's right, they're testing its understanding of the logic it's learned from the code.
Okay, that makes sense. But how do we know the AI is actually understanding the reasoning behind the code and not just memorizing patterns?
That's a great question, and this is where Codio really shines. They incorporated what's called chain of thought, or key OT, explanations into the process.
CodeI, I've heard that term before. It's basically like the AI thinking out loud, right? Explaining its reasoning process.
Right. They use DeepSeek-V2.5 again, this time to generate these code T explanations alongside the AI's responses, so we can actually see how it's arriving at its answers.
So it's not enough for the AI to just get the right answer. It has to show its work, so to speak.
Exactly, and that's what makes CodeIO so innovative. It's not just about training AI to be good at code, it's about teaching it to think logically and explain its reasoning.
Wow, okay, so we've got raw code transformed by DeepSeek, turned into input-output pairs, and then the AI gets quizzed with prompts and has to provide those code explanation. It's a pretty interesting process.
It is, but it seems to be incredibly effective. We haven't even gotten into CodeIO++A, which taken this to another level by incorporating feedback and revisions.
Well, you certainly piqued my curiosity. Before we dive into the plus plus version, I'm really curious to hear about how they tested this whole thing. How do we know if training on code actually makes AI a better thinker?
That's the million-dollar question, and that's where the benchmarks come in. I used a whole battery of them to see how CodeI stacked up.
Okay, let me get into those results. Did CodeIO live up to hype?
And these weren't just any benchmarks. They picked tests specifically designed to assess all sorts of reasoning skills, from common sense and scientific thinking to math problem solving and logic puzzles.
So, a real mental obstacle course for the AI. They wanted to make sure it could generalize what it learned from code and apply it to other areas. That's cool. What did they find? Did CodeIO actually make the AI smarter?
It did. Actually, CodeIO and CodeIO++ all consistently outperformed other training methods in large data sets across pretty much all the benchmarks.
Wow, really? So, training on code actually beat out other approaches that use like tons of text data.
Yeah. They even compared it to data sets like WebInstruct and OpenMathInstruct 2, which are massive and specifically designed for AI training. But CodeIO still came out on top.
Interesting. So, it's not just about the amount of data, it's about the type of data. Code seems to be packing a bigger punch when it comes to teaching reasoning.
Exactly. And there's another interesting thing. Those other data sets, while huge, often led to improvements on some tasks but declines on others. It was like a trade-off.
So, they were making the AI super good at one thing, but maybe at the expense of other skills? Sound like a student who only studies for their favorite subject and bombs the rest.
That's a great way to put it. But CodeIO showed consistent improvements across the board. It was like a well-rounded student acing all their subjects.
A real overachiever. Okay, so CodeI clearly excels when it comes to training data. But you mentioned something earlier that caught my attention. Just training on raw code directly didn't work as well. Why is that?
Yeah, that's an important point. They actually tested this using the Python edu dataset, which has tons of raw code.
So what happened? Did it still produce those impressive results?
Not even close. The improvements were tiny, sometimes even negative compared to no code training at all. It's like the AI was drowning in all that code and couldn't make sense of it.
So it really highlights the importance of that structured approach Codio takes, right? The transformations, the input-output pairs, the code explanations, it all seems to make a big difference.
Absolutely. It's not just about the code itself, it's about how you present it to the AI. Like a good teacher knows how to break down complex concepts and make them easier to understand.
Right. So let's talk about those benchmarks. What were some of the standout results? What areas did Codio really excel in?
Well, I was really impressed by the performance on tasks that go beyond just coding skills. Like Codio showed major improvements on benchmarks like Wino Grande, which tests common sense reasoning.
Ah, so like those tricky questions that seem easy for humans but trip up AI, like if you drop a glass, what happens?
Exactly. And it also did really well on DROP, which focuses on numerical reasoning in reading comprehension.
So even though it's trained on code, it's learning skills that are useful for understanding everyday language and situations. That's pretty remarkable.
Right. It suggests that the reasoning skills it's learning from code are transferable to other domains. It's not just becoming a better coder, it's becoming a better thinker overall.
That's fascinating. What other benchmarks stood out to you?
The performance on symbolic reasoning tasks was pretty mind-blowing. There are benchmarks like BBH and Zebra Logic that test the AI's ability to manipulate abstract symbols and solve logic puzzles.
Okay, now those sound like some serious brain teasers. Did Codio manage to crack those too?
It did, and that's a big deal because it shows that this method is helping AI move beyond just number crunching and pattern recognition towards a deeper understanding of logic and abstract thinking, like getting closer to how humans reason.
Wow, that's impressive. Okay, so far it sounds like Codio is knocking it out of the park. But were there any limitations, any areas where this approach didn't work as well?
Well, they did do some digging into the training process with what they call ablation studies. Basically, they remove or change certain components to see how it affects the performance.
So like a controlled experiment to see what really makes a difference.
Exactly. And one thing they found is that simply rejecting incorrect responses during training actually hurt the performance.
Wait, so throwing out the bad answers made the AI worse? That's counterintuitive.
It seems counterintuitive, right? But it seems like even those incorrect responses have valuable information about how the AI is learning. By keeping those mistakes in and letting the AI revise its answers based on feedback, it actually learns more effectively.
Ah, so it's like even AI needs to learn from its mistakes. It's a good reminder for all of us, really.
I agree. Another interesting finding was that the model used to synthesize those CodeI explanations really matters. They compared DeepSeek v2.5 to other models, and DeepSeek consistently produced the best results.
So the teacher, or the way the information is explained, also plays a crucial role. DeepSeek must be a pretty talented explainer.
Yeah, it seems that DeepSeek's ability to create high-quality, detailed explanations is a key factor in CodeIO's success. But we're just scratching the surface here. There's a lot more to explore, like that multi-turn revision process in CodeI Plus and the importance of the two-stage training approach.
All right, well, you've definitely piqued my interest. Let's dive deeper into those finer points and see what else we can uncover about CodeIO. All right, let's talk about that multi-turn revision process you mentioned. CodeIO++ seems to take this learning from mistakes thing to a whole new level, right? It's like having a tutor who walks you through the corrections.
Exactly. It's this really cool feedback loop built into the system. So in CodeIO, if the AI gets something wrong, it's kind of a try again situation. But with CodeIO Plus, it gets specific feedback like, hey, this answer is incorrect because of X. And then it gets another shot at revising its answer and the CodeIO explanation.
So it's not just about being right or wrong, it's about understanding why it was wrong and then actually correcting its thinking. That makes a lot of sense.
Yeah, and the research actually found that the biggest jump in performance happened between that first attempt and the first revision.
Interesting. So it's like that initial, moment when you realize your mistake and correct your thinking. That's where the real learning happens, even for AI.
It seems that way, and it also makes the training process more efficient because you don't need to waste time generating and evaluating tons of revisions.
Smart. Okay, now you also mentioned a two-stage training approach. What's the deal with that? What are those two stages?
Sure, so in the first stage, they train the model purely on the CodeIO data. It's all about building those fundamental reasoning skills, like learning the logic and problem-solving strategies embedded in the code.
So it's like laying a solid foundation before moving on to more advanced stuff.
Exactly. Then in the second stage, they switch to general instruction tuning. This is where the model learns to follow a wider range of instructions and apply those reasoning skills it just learned to new tasks.
Okay, so first it masters the logic of code, and then it learns to generalize those skills to other situations. I like it.
Yeah, and their research shows that this two-stage approach really works. It consistently outperformed other training strategies. It seems that mastering one area before moving on to others helps the AI build a more solid and adaptable skill set.
That makes sense. Okay, we've covered so much today. We've gone from the basic idea of CodeIO to its stellar performance on those benchmarks. What does all this mean for the future of AI, though? What's the big picture here?
Well, I think this research has some pretty profound implications. First of all, it challenges this whole idea that AI needs mountains of text data to learn how to reason.
Right, CodeI is showing us that code can be a really powerful alternative, maybe even better in some ways.
Exactly. We might have just stumbled upon a whole new way to fuel AI learning. But beyond that, I think CodeIO has the potential to lead to the development of much more robust and versatile AI systems.
So AI that's not just good at one thing, but can tackle a whole range of problems that require complex reasoning and decision-making.
That's the idea. Imagine AI that can help us solve challenges in science, engineering, medicine, even the arts.
Okay, now you're talking. AI that can not only write code, but also analyze scientific research, design experiments, come up with new medical treatments, or even compose music. The possibilities are pretty mind-boggling.
Right, we could be on the verge of a new era of AI where it's not just a tool, but a true thinking partner that can collaborate with us to solve some of the world's biggest challenges.
I like the sound of that. A real partnership between humans and AI. It's exciting and a little bit scary, all at the same time.
I agree. And while there's still a lot more research to be done, I think CodeIR is a huge... Oh, hey, our listener wants to join in. What's up?
And can you remind me the two stage of the training? So first stage and difference. What's the difference between the first and two stage?
Of course. We could definitely clarify the two-stage training.
And as for operator training, I'm not sure what you mean by that.
Yeah, we're not exactly sure what that is, but we can go back to the stages.
So let's unpack this a bit.
In the first stage, the AI is trained exclusively with CodeIO.
Think of this stage as boot camp.
It is focused on learning those reasoning primitives.
It's designed to expose the model to the underlying logic in code.
The second stage is where things get generalized.
The AI gets exposed to a broader range of instructions and tasks.
It gets to apply those reasoning skills learned to new situations.
So it's not just about code anymore, it's about reasoning.
Hopefully that clears things up a bit for you.
As we were saying, I think CodeIO is a huge step.
It's a really promising